This is the Magnetic Fields Homework Booklet, question 14. Which of the following is correct? An electron follows a circular path when it is moving at right angles to. So pause and think here about the conditions required to achieve a circular path. So when we think of circular motion, one of the key characteristics is that there is a force acting that is perpendicular to the direction of motion. We would call this the centripetal force. So considering a moving electron, that is a charged particle, you should remember that a charged particle moving in a magnetic field experiences a force equal to BQV. The direction of this force is given by Fleming's left-hand rule. If you want to just check that out, I've given you an example here. So if a magnetic field was into the paper, you could put your first finger of the left hand pointing downwards into the page here. If the electron was moving from left to right, then conventional current would be going right to left. So your second finger needs to point from right to left. That will leave your thumb pointing vertically downwards. So you see, motion in this direction experiences a force perpendicular to that in this direction. As the direction of the motion then changes, this force remains perpendicular to the motion. So when the electron's moving in this direction here, the force will have changed direction like this. So that is indeed a centripetal force, and you can select answer A. If you consider a uniform electric field and the effect that that would have, if an electron was moving as this one is from left to right, and there was a field acting from negative to positive in this direction, or positive to negative, then the electron would experience a downward force as in this diagram here. But the force would remain downwards all the time rather than changing direction as the path changes. The force would always be from negative plate, say, towards positive. And so that would give you a parabolic path, just like you get when the force of gravity acts on an object that is thrown to produce a parabolic path. The third example here talks about an electric and a magnetic field both acting together. That's an interesting case because it is possible to set up a situation where the force due to an electric field, which would equal charge times electric field strength, is equal and opposite to the force due to a magnetic field. And if you make them exactly equal and opposite, you can make a particle go straight on. And that can be used in a velocity selector, as the size of the magnetic force depends on the velocity. And that is part of a mass spectrometer that you have come across. The last option is more complex and will clearly not produce a circular path. In that case, you could, for example, have an electric field going in or out of the paper here, and that would give a force in or out in this direction here, which would mean the resultant force would be a diagonal between the two directions. So you can reject that. But you should recognise the first one as a classic case of something that can produce a circular path.